Hello, my name is Rob Winch, and welcome to Getting Started with Spring Security 3.2. A little bit about myself before we get started. I'm the Spring Security and Spring LDAP project lead. I'm also a committer on the core Spring framework, and I'm co-author of the Spring Security 3.1 book. You can find me on Twitter at Rob_Winch if you have any questions regarding this or just want to see what's going on with Spring Security or anything that I'm working on. Feel free to go ahead and follow me. Enough about myself. Today's agenda. We'll start off by talking about what is Spring Security. So if you're totally new to Spring Security, we'll go ahead and cover that type of audience. And then we're going to talk about what's new in Spring Security 3.2. So if you've already used Spring Security but are just wanting to learn some new things about Spring Security 3.2, we'll be talking about that as well. And then we'll back all the information that we provided up with a demo and some live coding. And the live coding will focus on, again, new users to Spring Security, but also users that are just coming to Spring Security 3.2. So before we can talk about what Spring Security is, we need to talk about what Spring I/O is. Spring I/O is the platform that used to be just known as Spring, and it's the collection of all the modules that are a part of Spring. So some of the modules you're probably familiar with. There's the Spring framework, which it provides some of the very core functionality like dependency injection and aspect-oriented programming. And then there's, of course, Spring Security, which we'll be talking about in much more depth today. Groovy is another part of the Spring I/O platform. Reactor is a event-based programming model that allows you to easily do fast data on JDK. It doesn't require Spring Framework, but it does provide very nice integration with Spring Framework if you want. Spring Data is another really nice part of the Spring I/O platform. You can define interfaces that follow certain conventions, and using those conventions, Spring can automatically generate an implementation for you. And it works with both relational and non-relational databases. So if you haven't checked out Spring Data, go ahead and check that out. Spring Integration, Batch, and Big Data are all types of ways of dealing with data. You can check out their respective modules within the Spring I/O website. And then the web modules. So you can also do things like web applications, RESTful services using Spring MVC, or WebSockets. And of course, there's also the execution layer. The execution layer is probably the highest level of abstraction and provides a very easy getting started experience. So Grails is probably the most popular one since it's been around for the longest time. It's a full stack web framework, and it provides a similar experience to things like Python with Django or Ruby on Rails. And there's also Spring Boot. If you haven't heard of Spring Boot, it's a very easy way to get up and running with Spring. You can fit an entire Spring web application within a tweet. Of course, that's a hello world application, but it shows you that it's very easy to get up and running. Spring XD is a runtime for doing large data processing, so you can use DSLs for creating streams and taps. And it's basically the glue that holds a lot of the other things together, like integration, batch, and big data. All right, so enough about what Spring I/O is. What is Spring Security? Spring Security's primary focus is authentication and authorization. What do I mean by authentication and authorization? Authentication defines the who. Who's trying to access a particular resource? And I identify the who in a number of different ways, but one of the most common ways is using a username and password. And you might store that username and password in a number of different data stores. For example, in-memory will help you get up and running quickly. And if you want to do something like LDAP or JDBC, then you can also do that. All of those are provided out of the box with Spring Security. But there are other ways to identify the who. For example, you might do a single sign-on mechanism that uses tokens or SAML assertions, or you might do something like OAuth. All of these are also supported by Spring Security. Once you've identified the who, then you need to determine if they're allowed to access the particular resource that they're accessing. And that's where authorization comes into play. Given I know who's trying to access a particular resource, are they allowed to? And this can be done in a number of different ways, but in the most common situation with web applications, you'll secure your application based upon URLs or something in the HTTP request. For example, you might state that if a URL begins with /admin, then only admin users are allowed to access that particular resource. And then you might also want to do something like if the URL starts with /public, then anyone can access that particular resource. But you can also do more complicated things. So for example, if you wanted to have read access for anonymous users and write access only for users who have authenticated, you might do something like if the HTTP method is a GET, then allow any user to access it, and if it's a POST, then allow only authenticated users to access it. There are countless ways of doing so, but once you've secured your web layer, you want to make sure that you also secure your service tier. This provides defense in depth, or security in layers. And Spring Security can do this easily using annotations. It could be as simple as something like, you must be an admin user in order to invoke this method, or as complicated as taking the arguments to the method or the return value of the method and comparing it against values with the currently logged in user. We'll go over that in more detail later on in the presentation, so don't worry if that doesn't make sense at the moment. Spring Security also provides protection against common attacks. So one such attack is session fixation. Session fixation is where a malicious user establishes a session ID and then tricks a victim into authenticating using that session ID by perhaps sending the session identifier in a URL. Once the victim authenticates with that session identifier, the malicious user can then impersonate the victim. Spring Security is able to protect you against this by invalidating the session and then copying the session attributes over to the new session as soon as the user authenticates. This means that if the malicious user does pull off the attack, the session identifier that they're aware of is no longer valid anyways. And what you'll notice that's very nice is even if you aren't aware of some of these attacks, Spring Security is going to protect you from these attacks out of the box. Spring Security also provides servlet API integration. So if you want to interact with the HTTP servlet request or other standard APIs in order to get information about your users, you can do so. For example, the HTTP servlet request allows you to get the current user or determine if the user is in a particular role. All of these are implemented by Spring Security out of the box, and you can just interact with the same HTTP servlet requests that you would if you're using container managed security. There's also optional integration with Spring MVC. We won't go into detail about that right now, but we'll talk about it very shortly. Finally, Spring Security is portable. And you might think, well, if I'm trying to be portable, wouldn't I use container managed security? That may be the case, but you got to think about the standard. Yes, it is a standard, and containers have implemented it, but it leaves a lot of things open to interpretation and doesn't define many things as well. For example, how do I configure my application? In container managed security, this isn't specified by the specs, so all the implementations of containers have different ways of configuring them. If you switch from one container to another, then you have to update your configuration, which can actually be quite tedious. Furthermore, the dependencies for the security are often stored in a parent class loader, and this can cause all sorts of class loading issues that cause things like permgen leaks or no class def found errors, depending on how things are set up. Whereas Spring Security is all contained within the WAR, except for your environment-specific information, of course. You might want to point to a specific data source or LDAP point, or maybe a specific endpoint for single sign-on. But everything else is contained within the WAR. So if you have 10, 15 developers or more developers, then you don't have to set up the security for every container. You just set it up for the WAR, and the engineers are able to reuse that. Furthermore, if you have multiple environments, like a development environment or a pre-production environment and then a production environment, you don't have to set it up for those either. So Spring Security offers a lot of advantages in terms of being portable. What's new in Spring Security 3.2? Spring Security offers new concurrency support. So when you're using a user's identity, it's typically tied to a thread local. And that thread local is obviously bound to a thread. And when you're switching between threads, because you're trying to execute something in the background, that thread local is no longer valid. So Spring Security provides abstractions that allow you to transparently propagate your user's identity from one thread context to another, and then safely clear it out after the thread is executed. Servlet 3 and 3.1 integration. There's a number of new methods on the Servlet 3 and 3.1 specifications that are related to security. For example, Servlet 3 added support for login with a username and password. Logout is another example. Both of these are now integrated with Spring Security by default if you're using the Servlet 3 or 3.1 specification. Also, Servlet 3 adds support for executing background tasks using the HTTP Servlet request. So this is to support async requests. And if you have a user's identity on the original thread, you need that propagated most likely to the new thread being used in the background. Spring Security automatically provides integration to propagate that identity to the new thread. Then Servlet 3.1 adds also support for changing the session ID. We talked earlier about session fixation attack and how we had to create a new session and copy all the attributes over. This can be fairly costly in a clustered environment where there's lots of information being copied over from many different boxes to other boxes. So with the change session identifier, the implementation is likely optimized to not have to copy all that information and only update the session ID of the user. And of course, Spring Security will use that strategy by default in Servlet 3.1 environments. If you're not using Servlet 3.1, it will fall back to one of its previous strategies. We mentioned earlier that there's Spring MVC integration with Spring Security. One of those examples is Spring MVC offers async support. And just as we did with Servlet 3 specification, we use the concurrency support within Spring Security to provide automatic propagation of the user's identity within Spring MVC async tasks. There's other types of Spring MVC integration that we'll talk about shortly, but that's just one example that we have. There's also cross-site request forgery protection. Cross-site request forgery is another type of attack that allows a malicious user on another website to submit a request to a site that you're logged in as. So for example, if you're authenticated to your bank's website and you forget to log out and go to another website, and that website submits a request from its own website, it can actually do something like transfer your money from your bank account to its bank account. And Spring Security provides mechanisms to protect against that we'll discuss in much more detail later. There's also security header integration. What do I mean by that? There's HTTP response headers that are very directly related to security, and Spring Security is now providing some of those out of the box. The most obvious one is cache control. If you authenticate as a user and log out, and then a malicious user hits the back button, then you don't want the user to be able to see what the authenticated user had seen. Instead, you'd want to be redirected to something like a login page. And Spring Security does this for you now out of the box with the Java config, and it does it very easily with the XML configuration. To remain passive, you must specify one additional XML element. And you might say, well, I don't want everything to be prevented from being cached. I want to cache my CSS, I want to cache my images, and I want to cache my JavaScript. Well, that's fine. As long as you specify some other cache value, then Spring Security will back out of the way and it will be cached. And this is done by default with the Spring MVC resources. Finally, Spring Security 3.2 offers Java configuration support. In the beginning, there was the XML, standard XML bean definitions, and this was very difficult to configure. Then Spring Security provided an XML namespace, which is basically a DSL with XML to configure Spring Security. Now, many developers are using Spring's Java configuration support. So Spring Security 3.2 has implemented this to allow you to have a DSL for configuring Spring Security using Java code. And we'll go over that in much more detail with our live demonstration and coding. All right, so we've taken a look at some of the things related to Spring Security and what's new in Spring Security. Let's check out our demo application now. Our demo application is very simple. We have an inbox that allows us to display messages. We can view the details of that message. and we can compose new messages. So here we're going to create a message to Luke, and we need to make sure that our user is found. And once we've done that, then we can see that it's listed here as well. And we can also go ahead and delete a message. So you can see the functionality of this application is very simple, but that will allow us to focus on the security aspect of things. We can also go to our H2 admin console. And this is not something that we implemented ourselves. It's provided by H2 itself. So what we can do now is we can connect to it, and you can see that we're able to view our in-memory database. So I can view the messages. I can also view information about my users. And you can see that our application has a model for users where the email exists and a password exists for our users. One thing I'd like to point out is that our passwords are not hashed, and they should be hashed in a real application, but we won't have time to address this. Just know for now that you should hash your passwords, and you can use Spring Security's password encoders to do so. All right, so now that we've seen our application working, we need to figure out how we can secure it using Spring Security. Let's go over the steps required to secure our application. The very first thing that we want to do is we need to add our dependencies. And if we're using something like Gradle or Maven, it's very easy. We can just add the dependencies, Spring Security Config and Spring Security Web to our web application. Once we've done that, we are ready to start configuring things. Here you can see I've prepared a web security config, and it's annotated with the configuration annotation. This is just to instruct Spring, as you would with any other Java configuration, that this class is used to configure Spring. We also add an enable web MVC security annotation. This annotation basically says that we want to use Spring Security to protect the web environment, and we also want to have Spring MVC integration. If you're just using Spring Security with something other than Spring MVC, you would just say enable web security. But we want the Spring MVC integration because that provides us some nice features that we'll explore later. Finally, our class must extend web security configure adapter. This is providing us lots of reasonable defaults to get us up and running quickly. The name of our class is irrelevant, but we do want to extend this base class. Once we've extended the class, the only thing that we need to do is configure security. And to do this, the easiest way is to use the auto-wired annotation. The auto-wired annotation will then auto-wire Authentication Manager Builder, which is provided by Spring Security, and then we can add a few users using in-memory authentication. And once we invoke these methods, Spring Security will use that information to determine how to authenticate our users. All right, so you might be wondering, well, if this class already exists, why is our application still not requiring a login? Well, there's one more step that's required. And if you're familiar with Spring Security prior to Spring Security 3.2, you're aware that we also need to configure our web XML, typically with the Spring Security filter chain. And we do that in Java config just by extending a class. So our base class that we extend to ensure that our servlet is aware of the Spring Security filter and specify the ordering of that is abstract web security initializer. And once we've done that, we have now specified for Spring Security to intercept all our requests and to protect our web application from users who are not authenticated. So let's go ahead and start up our application and see what happens when we make a request to our protected resources. Now you'll see that I'm automatically redirected to a login page. And the login page isn't very pretty. Granted, it's cleaned up very easily, and we'll explore how to do that later. But we need to realize that this login page was not created by us. Spring Security automatically generated this for us so we could get up and running very quickly. Now we'll go ahead and authenticate with our user, and you'll see that I'm displaying the user and the logout button. And that wasn't displayed there before. So let's take a look and see how we're displaying that information. In this application, we're using Timeleaf, but you can use any view technology that you choose. So you could use JSPs, or you could use Velocity, FreeMarker, etc. But we're using Timeleaf because it's very nice Spring support, and you don't need to run Timeleaf in a container in order to render the values. So we can very easily test our values without having to start up a container, which makes things much quicker. So here you can see that I'm accessing the HTTP servlet request, and I'm getting the user principal off of it. Earlier we mentioned that Spring Security integrates with the servlet APIs, so all this is doing is it's invoking the HTTP servlet request, and it's getting the user principal. So this user principal is just invoking that. The question mark is just doing a null check on that user principal, and if it's null, it'll just finish the expression and return null to current user over here. Otherwise, it'll access the name property on the principal object. So this principal has a name object. And that's what we're using to display our user. And here we just say if the user is not null, then we render a form. And that form is our logout form. By default, we must do a post to logout. We'll cover why that post is necessary rather than a get, but by default, if you have cross-site request forgery protection on, you must do a post. And then finally, we also display our current user. And that's where that information is coming from. If we log out and log back in as our admin user, you will see that our admin user is displayed in our application. All right, so that was very easy for us to get up and running. Let's take a look and see how we can customize our login page. So the very first step that we want to do is we need to configure, adjust our configuration for Spring Security. And we can do that by just overriding a method in our configuration. And if you're getting started, you can just copy the values from our parent class. And that makes it much easier for us to get going. We have to do that within the method, though, which I accidentally messed up. So now we've copied that method, and we need to basically explore what this is actually doing. And what it's doing is it's securing all our requests to a particular to any request within our web application and requiring that the user is authenticated. And we're also supporting form-based login. And previously, we hadn't specified a login location, and that's why Spring Security is rendering our login page for us. So instead, we're going to specify an exact location, and that means that now if the URL/login is requested, then we need to now render a login page. And you'll also notice that if we're authenticated, it's going to send us to that login page. But since every request requires authentication, we need to grant access to our login page so an unauthenticated user can access it. And previously with XML configuration, you had to explicitly configure that. But you can also use, in Java config, a permit all method. This basically says that for any URL associated with form login, grant access to every user. This is just a convenience mechanism. It must be explicitly stated because within security, we don't want to make any bad assumptions. And so we don't assume that you aren't using this URL/login for something else that needs to be protected. If we did that, we might cause some security vulnerabilities for you. Instead, we make it explicitly required. And this is just best practice with security-related configurations. And we also want to configure our logout. And our logout is already configured, but we also want to grant access to all our logout URLs in the same manner. One of the things that you'll see with our login page is we have some CSS and images and stuff that need to be accessible from unauthenticated users. So what we can do is we can add a pattern here, and we can say anything that starts with resources. And we might also want to say a sign-up URL so new users could be created, permit all. So the thing is these methods are considered in order. So first we check to see if it's resources or sign-up, and then if so, it's permit all. Otherwise, you must be authenticated. If we switch the ordering of these, this second line would never be reached because everything matches any request. So keep in mind the ordering of these matters. Now that we've stated this new configuration, let's see what we can do to how we create our login form. Again, we're using Timeleaf in this instance, but you can use any templating technology that you want. So you could use JSPs. But the main things that you need to focus on are we must do a post to the URL /login. And that login URL is only because that's what we have configured here in our configuration. So HTTP GET renders our login page, and an HTTP POST validates the username and password. And the password that it validates is username and password must be specified in the parameters username and password. Of course, we can override those values. If we want to look in a different HTTP parameter, we can, but we're accepting the defaults. If we fail to authenticate, it'll redirect to /login with the query parameter error. And if we log out successfully, it'll go to the login page with the query parameter logout. And that's how we're displaying our error message and success messages here. So now that we've covered all that, let's take a look and see what we need, what our login page looks like now. Our application starts up, and you can see now our login page looks much more like the rest of our application. We get an invalid username password, and we can type in a username and password, and we can view that user just as we were doing before. And we also get a successful logout message. So we were successfully able to create a login page. But we noticed that there is an issue still with our application, obviously. We are still using our in-memory database or in-memory configuration for authentication. So we'd like to change that because we already have a notion of users. We already have a notion of users that we're sending messages to. So how can we fix that? Well, let's see how we can change this to be database configuration. I already have a data source configured, so I can easily just ask Spring to auto-wire the data source for me. Now I can change the configuration to use JDBC authentication. Bring this up higher, make sure you can see it well. And we specify the data source for JDBC authentication, and then we say with default schema. The with default schema is just saying use Spring Security's default schema that it uses for users and roles, and go ahead and ensure the database is populated with that. You wouldn't typically use that in a production environment. And you probably wouldn't specify your users in line here either. So now that we've done that, we can go ahead and start up our application. And you won't notice anything different from the external appearance of our application. We'll just authenticate as a user. And you'll see that I authenticate just as I was before. But you'll also notice that we go to our H2 console and we get an error message. What's that error message? Well, it says invalid cross-site request forgery token. Let's take a look and see what that's protecting us from by disabling it. So we're going to go ahead and disable that so we can access our admin console, or our H2 admin console. And the reason why that's happening for our admin console is because it's not generated by our application. So it's not aware of our cross-site request forgery protection. And there's also some security headers that are being used that protect you against another type of attack that we'll discuss momentarily. So let's go ahead and start up our application again. And now we authenticate as user and admin. And this time we'll go to H2 and we'll connect, and everything works successfully. And here you'll see that I have additional tables. There's an authorities table. This is Spring Security's default way of defining JDBC mappings for the users. And there's also a users table. But the issue is we have multiple mappings for our users. We have the users that we want to use and the users that Spring Security wants to use. We'll discuss how to consolidate those in just a moment. But let's see what we have done by disabling these protections that are built into Spring Security. The first one that we're going to discuss is cross-site request forgery. Cross-site request forgery is a type of attack that would happen from another site. So imagine this is some evil site, and it has a button called Win Money. You don't realize it's an evil site, and everyone loves to win money, so you decide that you want to click on this button. But before we do so, let's go ahead and take a look at what the HTML of this page looks like. Our HTML is basically a form that submits to localhost sample 100. And the method is post, and we have a hidden input underscore method value delete. This is actually the same HTML that we see within our application right here. And so we wonder what would happen if I click that. Well, the issue is that our users kept track of using a cookie, and that will automatically be submitted. So when I click Win Money, it actually removes the message because I'm still authenticated. And if you refresh this page, you see the message went away. So this is one type of exploit that we can use with Spring Security, or with the cross-site request forgery disabled. Let's take a look and see another type of exploit. This one looks very similar. Assume we're on an evil website again, and you see this button, and you like to win money, so you want to click it. Let's take a look and see what this HTML looks like. So this HTML is a little bit different. Our form is actually a form that submits to an action with the pound sign. So that's not actually going to go anywhere if it gets submitted. And then we have an input button that is of type submit, and it says win money. There's also an iframe at the bottom that loads the URL that we see right here. But we don't see that iframe. Let's see if we can modify. The reason for that is because of our CSS. So we're going to modify our CSS. And now we actually see the frame is actually on top of that button, and there's a delete button. Just to prove a point, let's see what happens when we compose a new message. If we create a new message, you'll see that now I have two delete buttons here. And if I refresh my page, there's two delete buttons displayed within that iframe. So you can see that this content is actually just the value of that page. All right, so if I change the transparency of this just to be semi-transparent, you can probably see that the win money button is actually right on top of the delete button. And so if I change it to transparent, what we're really doing when we click on this win money button is we're actually clicking on the delete button. So if we click on that button, you'll see that I was deleting the message. And if I do it again, it'll delete the additional message. So this is another type of attack. It's different in that we aren't actually creating the request on the malicious website. We're using an iframe to create the request for us. So let's see how we can prevent these types of attacks. Well, with Spring Security, this is pretty easy. If we hadn't disabled it in the first place, we wouldn't have had to worry about these attacks. So we'll just go ahead and disable them. And we'll start up our application again. And once we do that, we'll go ahead and log in as our user. And here you can see that I have the same page, and I'm going to go ahead and click on the Win Money button. And now I get that same error message that we saw earlier. So what's happening? What's happening is that Spring Security cross-site request forgery protection is expecting an additional value as an HTTP parameter. The cookie is automatically transmitted, but the parameters need to be known by the foreign website. And so what happens is when it doesn't include that value, or it doesn't include the correct value for underscore CSRF, then Spring Security says you aren't allowed to do any HTTP posts, delete, or any other types of methods that might change the values. So this is the other reason why in our application that the logout must be a post, because the logout is a way of changing state in our application. We don't want the malicious website to force our users to log out. We do the same thing with our login. And you might say, well, why does it work within our application? The reason is, we'll inspect this, is that the token's actually included. And this is done automatically using our Spring MVC integration and libraries like Timely that use that, or the Spring MVC tag libraries. So if you're using Timely for Spring MVC tag libraries, JSP tag libraries, it will automatically integrate with those. All right, so once we've, now that we've discussed how we're protecting against cross-site request forgery, let's take a look at our clickjacking demo. So if we look at our clickjacking demo, remember it's loading an iframe, and that iframe contains everything that's viewed in here. So this button actually has the token for cross-site request forgery included in it. So if I click on that button, it's actually going to submit the proper value. So we need something else to protect us against this type of attack. If I click on it, I'm clicking on it a number of times. You might not believe me, but you can try the sample later on when I send you the link to the sample code. It didn't actually delete anything. Let's take a look and see why that's happening. The easiest way to see what's happening is the X-frame options is set to deny. So this is basically Chrome is saying I won't render the sample web application in the frame because it's denying access. So how are we denying access? We're doing so using Spring Security's response headers. And among other things, you'll see that the X-frame options deny header is set. And you can do other types of frames. So maybe you want to allow the same domain. So you want to, if you owned example.com and you wanted to frame something from example.com, you can do that using same origin, or you can specify specific domains that are allowed to frame the content. But we're as strict as possible by default. There's a number of other security response headers, but I encourage you to go over those within the Spring Security Reference Guide rather than spending more time on these. All right, so that's why whenever we click on this, it's not doing anything. And just to illustrate the point one more time, we can go to our demonstration. And earlier, you remember we saw the buttons when we changed our CSS. You can see now that I see the border of the frame, but there's no content. And that's because Chrome is refusing to render the content due to that security header. So that's what's protecting us against a clickjacking attack. All right, so we've restored our security, and we realize that we have a different set of tables for our users. So how are we going to resolve those different set of tables? Let's go ahead and see how we can do that. We'll stop our application, and then we're going to update our config. And right now we're using the default data source, but we can also reuse our own custom queries. So here I copy pasted a query, select email password true from user where email equals question mark. And this is just a query that, given a username, will select a username, password, and true is just enabled. Is this user enabled? And we don't have that notion within our current model, so we're just going to hard code true. You could have an enabled value within your model if you wanted, and then actually query that. And that basically tells Spring Security how to create our user. But then we also need to know how to look up the roles that are associated with that user. So here we're going to select email, which is the username again, and the role from user where email equals question mark. Again, we don't have a notion of roles within our current model, so we just hard code role user. If you do have a notion of that, you can update the query accordingly. So we can go ahead and start up our application. And you'll notice that we log in with username and password, and it doesn't work anymore. And that's because we are now using our current user model. We didn't populate the users either. So instead, we need to authenticate with Rob and Luke. So now you see my username is updated accordingly, and I can still log out. And I still get the logout message. Everything else is working just as we would have expected. But you'll notice that I'm still actually having to maintain these queries, which is not good because I already have a mapping for my user information within the rest of my application. That's how the messages are resolving the users that are associated to the message. So how can I resolve that? Well, let's go ahead and use a user detail service instead. And we'll discuss this in just a moment. But for now, we're just going to update our configuration. And we also need to make sure that our existing user detail service that I programmed ahead of time for us is ticked up. So we just add a component scan here. And we just say that we want to scan the classes within our user repository user detail service. So let's take a look at this class. This is where our implementation of user detail service is. And it just has a single method, load user by username. So we look up the user, and this user details is Spring Security's notion of a user. It's an interface. And it just has certain methods on there that Spring Security uses to determine if the user has authorization to access a particular URL. But we also have our own notion of a user. And that's what we're doing here, user repository find by email. And this user repository is just our existing user objects that we already had before we added security. And it's using Spring data to look up the user. And once we find the user, then we just return a user repository user details. Well, what's that? This is just a class that extends our user object and implements user details. This means that Spring Security can treat it as a user details object, so it can make access control decisions, but we can treat it as a user object. So let's see how we can leverage that within, for example, our layout. Our layout here is currently accessing just the user's username. But now let's see if we can get the principal off of there. It helps if I spell it right. So now we got principal, and then we might want to display the first name of the user. And where's that coming from? Well, earlier we stated that the object is now both that we're returning is going to be both a user and a user detail. So our user object has a first name on it. So if you're creating your own user model, you can have all the attributes you want and access them very readily using the HTTP servlet request. Or if you're using Spring MVC, you can resolve that very readily using an annotation. So earlier we were noticing that our users are actually displaying messages that are not just to them but to other users. So instead, we'd like to update our data access within our controller. You'd probably put this logic within a service tier normally, but for simplicity, we don't have a service tier. So here, we want to resolve our current user. And that current user is used to find which messages we want to return for our inbox. So now we can just say current user, get ID. So now we're just finding, if you're looking at this, following along, message has a user that it's to, and that user that it's to has an identifier. And then what we're doing is we're basically finding all the messages for our current user. How does current user work? Well, this is just an annotation we included within our own application. And the authentication principle is provided by Spring Security. So Spring Security will look for this or an annotation with it on it. This just provides another layer of indirection. And it will automatically resolve the currently logged in user to that value. And you need that annotation because perhaps you don't know if Spring MVC wants to resolve the currently logged in user or maybe you're creating a new user or managing users within your application. So you explicitly state that it's the currently logged in user, and then you find those values. All right, so now that we've done that, let's go ahead and start up our application again. And we'll authenticate as Rob. And now you see that I'm only seeing Rob instead of Rob and Luke, and I'm displaying the first name of the user rather than displaying the user's email address or their username. But if I click on here, you'll notice that I'm also able to see my message, but if Rob's clever, he can modify this URL. And he's now seeing Luke's message, which he shouldn't be able to see. And the reason for that is because we aren't doing defense in depth. So let's take a look and see how we can protect our resource properly. We can easily do this using Spring Security's global method security. And to do this with Java configuration, it's quite simple. All we need to do is add an enable global method security, and then we state that we want to use pre-post annotation. So Spring Security needs to look for annotations that are pre-post, and we'll take a look at one of those now. So our message repository has an annotation on it called post authorized, which is provided by Spring Security. And what it's saying is that the return object, which is a message, has a field called to on it, and that has an ID on it. So the ID of that to property must match our current user's ID. And this principle, once again, is very similar to what we were displaying in our layout that we talked about earlier. That's just our current user object. So once we do that, we can now update our application. We can start our application. And if I authenticate as Rob, I can see my message, but if I try to access Luke's message, then I get access denied. So this access denied page is not probably what you are wanting, but what I would say is that you can customize this. So same with the other error message that we saw for cross-site request forgery. These are customizable. We won't have time to cover how to do that, but you can refer to the Spring reference on the main Spring Security page on how to do that if you need to customize that access denied page. All right, so we're able to do that, and then just to prove that Luke can still access his, but he can't access Rob's message. All right, so we've done this, but one of the things that you'll notice is that we aren't able to reuse our logic very readily within an annotation. So what we can do to make this even easier is we can use an expression called has permission, and then we're able to map that to an object that we have already defined, message permission evaluator, and what you'll notice is that has permission method actually maps to this, which we have defined custom. The authentication is a currently authenticated user. The target domain object is just the first argument to that method, which is our return object. And the second object is just read. So in here we can reuse our logic. If we had multiple annotations, we could reuse that to determine if the user has access or not. So we can start things up. And we can demonstrate that this still works, but we're able to reuse our logic now. So now I can see Rob, but I can't see Luke. All right, so that demonstrates how we can reuse that logic. And obviously, you could do much more complicated things within the permission evaluator if you so chose. But this is just a very simple implementation of it to show you how that could work. And one thing I'll point out is the reason why that works is that that object was already being picked up by our component scanning, and since there was a permission evaluator bean existing, our global method security automatically supported using that. So that's how that was working. All right, so now that we've got everything working, let's see how we can test things. We're only going to skim over that very briefly, but we have some tests in here that you can refer to at the end, and you'll see that these tests are using Spring's mock MVC support. And what we do is we just auto-wire our Spring security filter chain. This is just that filter that we had to add at the beginning. And we add that to mock MVC so that it's protecting everything. And then we could do certain types of tests. We can perform a get to ensure that we get the login page. We can then also say, if I try to request the root URL with the user Rob and the role is user, then I will expect to get only Rob's messages back. And you can do all sorts of validation within here. And one of the things that I have to point out, though, is that mock MVC and Spring Security are not necessarily very easy to use together with the current release. And the reason for that is we just didn't end up having time. So this will be included with Spring Security 4. And in the meantime, you can copy from this example and reuse this. This is fine. It's going to work just fine. The only reason why we didn't release it is because we weren't quite sure how we wanted to structure the code and the tests and if we liked the names of methods and that sort of thing. So we wouldn't be able to make non-passive changes to this once we released. So for now, you guys can just copy-paste this. And if you wanted, you could continue using that even after Spring Security adds official support for it. So take a look at that to get an idea for more examples on how to do that, to do our testing. And that actually concludes our demonstration and sample code for today. If you're wanting to get a hold of the sample code, it's all available out on GitHub. My GitHub ID is rwinch. You can see a full URL there to the presentation. And the slides are available in that same GitHub account, GitHub repository. And Spring Security has a URL, spring.io/SpringSecurity, to get more information, including the reference. And if you're wanting to just keep up to date with Spring Security, myself, what I'm doing, or Spring in general, go ahead and follow us on Twitter. And if you have things that you'd like to comment or talk about, feel free to ping us on there. But remember, keep things short on Twitter. If you have something more complicated, use something like Stack Overflow and maybe ping with a URL to the Stack Overflow question. It gets very difficult to talk on Twitter very long. And, of course, you can find other talks on spring.io/video. And that's it. We can open it up for questions now.
Fabulous. Thanks, Rob. First question, we've only got about 6 questions at the moment, so we should be able to finish up pretty quickly. Rahul asks, is SSO support possible across multiple Spring MVC web apps using Spring Boot?
Is SSL possible across multiple?
I'm sorry, SSO, single sign-on. Sorry, I shouldn't have abbreviated.
Not a problem. Single sign-on. So
make a little more sense now.
Yeah. Well, I mean, the other question actually did make a little bit of sense as well. But yes, that is possible. You would just set up single sign-on, however you're doing it, just as you normally would. So if you're using, for example, SAML, you just set it up in your Spring Boot application as you would with standard Spring-based security. If you're using OpenID, you would set that up just as you normally would. So at that point, Spring Boot would be backing out of the way and using your custom Spring security configuration.
Excellent. Thank you, Rob. Zeka Stevenson asks, does this new version have anything new, easier to use single sign-on with Active Directory?
No, this release does not have anything to help with Active Directory single sign-on.
However, we do have a Spring LDAP release.
There is, but it's not going to probably solve the single sign-on that they're talking about. If you're interested in such a feature, I encourage you to log something in Jira, either to Spring Security or Spring LDAP, and just make sure you're very detailed on what you're looking for, and it can be considered for inclusion. One of the things that makes something like that very difficult, especially with LDAP, is LDAP has all sorts of different setups, and so with great flexibility is one of those things of great power comes great responsibility. It's very difficult to make things easy with all that flexibility. But if you have something concrete, please log a Jira, and we can certainly consider it for inclusion in either Spring Security or Spring LDAP.
And just an aside on that, you folks on the phone, you may roll your eyes when you hear, something like, hey, Internet Jira ticket. We really pay attention to that stuff. In fact, the entire Spring Boot project came from a piece of feedback that we got from some developers directly. So we do listen to that stuff. We take it seriously. So I just wanted to say that really quickly.
And to expand on that real quick, Peter, is that's actually how I prioritize what's going in the next release. So, voting and stuff like that is definitely taken into consideration in terms of what's included in the next release. So log the tickets. It makes it easier for people to vote for them, and that's certainly used to determine what are the next steps for our releases. Yep.
Tobias asks, does CSRF integration work with a JavaScript app like AngularJS? Angular by default passes the CSRF token as a cookie. Seems like we've heard this question a lot today, huh, Rob?
Could you reread the last part of it, though? I just might need to clarify something.
No problem. The last part is Angular by default passes the CSRF token as a cookie.
Angular passes the token as a cookie. That doesn't, the CSRF token or the JSession ID token, it should not actually do it as a cookie, maybe as a header, but probably not as a cookie, because if you do it as a cookie, then you basically have mitigated, basically you're exposing yourself to the same issue that cross-site request forgery is protecting against. So if you want to include it in a JavaScript application, you should probably do so with a header. And there's instructions on the Spring in the Spring Security reference on how to do that with something like jQuery or CUJO.js. But yes, you can do it with JavaScript, and you should include it as a header and not as a cookie. If you do it as a cookie, you have broken everything.
Right. I think also, if I'm reading in between the lines of Tobias' question, I think he's just kind of fishing for, what is the level of compatibility between AngularJS and Spring Security, and possibly, Spring in general. So, it sounds like from what he's saying, Angular passes it as a cookie. So I don't know if he can work around that or not. But Tobias,
I don't think it actually does. I think maybe he had a typo. If not, please feel free to clarify either on the questions here or ping me on Twitter. But I would be very surprised if it included it as a cookie.
Yep.
It probably includes it as a header. Cookies are also headers, but it's a special type of header that the browser automatically sends. So please feel free to clarify if you want, or re-ask, or provide an example to prove me wrong. I've been wrong before, but I'd be very surprised if it did.
Yep. Okay. Hang on one second. I'm just curious. Since we don't have that many questions left, I'm just taking this little extra bit of time. It does look like Tobias is still on the phone. So if you can hear this, please feel free to clarify. In the meantime, Raghu asks, in a real-world application with a lot of roles, a lot of users, a lot of pages, and context-dependent user actions, how do we capture the access model? Meaning, which roles have access to which sections of the screen and or actions? There's
actually an API that allows you to do this, and if you're using for example, JSPs, Spring Security has tag library support, so you could say, is the current user allowed to access a particular URL, or is the current user allowed to access a particular object? So earlier we saw the has permission within our Spring Security code on the annotation. You can also use similar expressions within those tag libraries. Timeleaf also has similar support, but behind that there's an API that you can use to actually check the access on individual objects. And in fact, there's actually a whole section in the reference, if you look at the ACL portion of the reference, that discusses this in much more detail. There's also the contacts application, I didn't enunciate that very well, contacts application that demonstrates this in great detail as well.
Awesome, thanks. Raghu further asks, is there a way to capture this outside of the source code? Outside of this, do they mean specify the information outside of the source code, or do they mean export the information? I guess I'm not quite sure what they mean. Yeah. Is there a way to capture? You want to? Yeah, are you? If Raghu is on the line, are you trying to provide the information to? Are you trying to basically define your permissions in a database or something like that, or are you trying to, given the current Java configuration, export it to a file that you can view? What are you trying to do? Yeah, so Raghu, it appears you're still on the phone. If you want to clarify, please, by all means, go right ahead. So just taking a stab at that, you can define it in an external database if you want, and that's where you would use something like the permission evaluator. We demonstrated how you would do that with hard-coded checks within the permission evaluator, but you can implement that any way you so chose. So that's how you would do something like putting the permissions in a database. And Spring Security actually provides an ACL model that can be in a database out of the box. So again, refer to the reference to see how to do that. Holy cow. Okay, we just got a ton more questions. What's your time cutoff today, Rob, for this? I probably have till 1:15 my time, so I guess that's 10 minutes. 10 minutes. Okay, let's pick up some speed then. Sri Bandari asks, can we apply Spring Security to REST APIs and use OAuth 2? Yeah, you can. Check out it. A very good sample application for that is, if you are looking for it, is Josh Long has posted the Spring REST stack. Just Google for Josh Long's the Spring REST stack, and it talks about how to do OAuth with Spring REST applications. Perfect, thanks. I'll plug that into the chat window for Sri as well. Tobias M. asks, does Spring Security support sharing sessions across multiple deployments of the same web app? Sharing sessions across, that's typically, so the session itself is typically handled by your container, but you can implement HTTP, you can implement an interface, the security context repository, and then your user's identity information, such as basically stuff specific to Spring Security, can be stored anywhere, so you could put it in like Redis or something like that. In terms of the entire session, Spring Security does not really address that. You'd have to refer to your container to do that, and many containers actually allow you to plug in NoSQL databases for your session implementation. So I'd basically refer to your container documentation on how to do that. Next is, does the earlier Spring Security versions not handle the CSRF itself? Correct. Cross-site request forgery protection is new in Spring Security 3.2. Yep. Okay, just checking. Pivotal Toronto. Hey, we got some pivots on the phone. Folks, I'm just going to try and answer some of the attendee questions first, if you don't mind, and if we can get to yours, we will. Ben Hidalgo asks, what do you recommend for implementing OAuth on REST services to support mobile and web clients? I'm tempted to point him at that Josh Long code sample again in the webinar.
Yes, I think that's probably a good. Josh and I actually worked on refining the security aspect of that together a little bit, so that's a very good example.
Ben, also, if you give me a second and hang on, there's also some great YouTube videos that from Spring One and elsewhere that we've talked about OAuth in some detail, also as it regards REST. So there's a lot more information on spring.io/video. Got a lot of talks related to OAuth and REST as well. A lot. Let's see. Spring Security support OAuth 2.0. I think that's an easy one.
Yes, it does.
Okay. And he's saying it can get
just to clarify, that's with the Spring Security OAuth extension. But yes. Right.
Yeah, he's interested in the ability to refresh tokens once the access token expires from providers like Google, for example. Let's see. Okay, wow, a lot more stuff coming in. Good. Tobias clarified his earlier question, and he put in a link to the AngularJS. We're talking about the cookie versus not cookie. So he's saying, let's see. Okay, yeah, XSRF is a technique by which unauthorized sites can gain your user's private data. Angular provides a mechanism to counter XSRF. When you do an XHR request, the $HTTP service reads a token from the cookie, by default an XSRF token, and sets it as an HTTP header, apparently. Or it says, I think he means to say header. I just see it gets truncated and says HTTP-H, which I assume to mean header. But anyway, a little more detail there. It sounds like, Tobias, you might want to ping Rob on Twitter and go into a little more detail with him there. I think we've got just a couple more questions. We've probably only got about 3 more minutes with Ron today. So let me see if I can get to those last ones.
Tobias, I was going to just add one more thing. There's actually a guy that I was discussing AngularJS with that wrote a blog post about AngularJS and cross-site request forgery protection. And he actually asked a question on how to get that to work and posted a pretty nice blog that I helped him update to use a better way of doing it. And I'm trying to actually find that right now. Actually, I just found the link to... actually, I take that back. He's using Backbone. I apologize. But it would be fairly similar for an AngularJS application. But feel free to ping me on Twitter if you have any questions on that specifically. But I don't think they're including it as a cookie. If they are, then they probably need to talk to someone from a security background because it shouldn't be in a cookie. Unless they're only reading it. Unless they're only reading it from the headers, which is okay. If they're only reading it from the headers, that would be acceptable. Basically you have to include it as a header in order for it to be supported. So if that's the case, then that's okay.
Gotcha. 1 or 2 more questions. Srikant asks, can the Spring Security ACL database schema be implemented in Mongo?
It could, but it's not currently. I mean, anything's possible given the right amount of time. The issue right now is probably just time. The other thing that I will add is that ACLs, as implemented with Spring Security, can certainly be improved because one of the issues that you run into is if you're doing paging, you're checking the values afterwards to see if you have access. Doesn't work very well. You need to actually update your queries as we did in our example application. And so, you really need to actually update the queries to do that. There is some very initial talks on doing Spring Data and Spring Security integration that would help with that. And if that were the case, then we probably would do a Mongo implementation as well. But basically what I would say is make sure that you realize that you still need to update your queries because otherwise you aren't going to scale trying to say, give me all the images that I have access to, and then having to go through each of those and, in memory determine if the user has access versus having the database determine that.
Yep. All right, I think we're at time. There are 2 remaining questions. Yay or nay?
Let's go ahead and squeeze them in.
Okay. Few words about cross-domain authentication and Spring Security, please.
Cross-domain authentication, that's pretty vague, so you're probably going to not necessarily get the answer you're looking for. But cross-domain authentication is typically going to use a single sign-on solution of some sort. So, for example, you would use something like, a lot of people use OAuth for authentication. You could also use something like SAML or CAS or OpenID. So those are all options for single sign-on. Each of them have their pros and cons, and it just depends on your situation which is the right solution.
Got it. Last question is from our brethren in Pivotal Labs, Toronto. How do you propagate the security context across background threads without the parent-child relationship?
Basically what happens is that Spring Security has its own executor interface, which is what's used to submit a runnable to. And then when you submit that runnable, Spring Security automatically decorates that runnable with something that establishes a security context just prior and then clears it out just afterwards. If you want to see a concrete example of this, again, check out the Spring Security reference, which you can see there's a link to just Spring Security, and then from there you can click on the reference guide and just search for the async support. And it'll actually give you some concrete examples explaining how that works.
Fabulous. I think we did one. There's one last question. I'm having trouble reading it though, so I think I may have to. Yeah, it's a little hard to read. So I think we may need to call it at this point as we're 12 after. Rob, thank you very much. Really appreciate you answering all the questions. And I just want to let folks know that we've got some interesting webinars coming up. In February, we're going to have Introduction to Apache Tomcat 8, and we're also going to have a webinar on Spring Data Repositories Best Practices from none other than Oliver Gierke and Thomas Derrimont, our two of our project leads on Spring Data. And we are doing a couple overflow webinars for the Spring Introduction to Spring Framework 4.0 event in January. We had so many people register, it actually broke WebEx. So we're hosting a few additional webinars on January 23rd. If you were one of those people that was denied and had a little trouble getting on, we're holding open some more events for you. But we have to limit the registration to 1,000. So please look us up. The tweet I just posted a few minutes ago, if you're interested in attending that Introduction to Spring Framework 4.0 with Jürgen Holler on January 23rd. And then we hope to see you back in February for the Intro to Apache Tomcat 8 and Spring Data Repositories Best Practices. We'll be posting those very shortly to the website. They're not up yet, but the registration for those will be opening very soon. With that, Rob, anything before we call it a day?
That's all I have.
Awesome. All right, great. Thanks, everyone. Really appreciate your time and attention, and look forward to seeing your comments on the release and your comments on Twitter. Have a great day.
Thanks, everyone.